this is number 7 on the list of 8 that we have. And this is also a no power, it's a 15 inches. So what does it say? So it says device, it's okay, device doesn't start. Reason why problem is okay, device doesn't start. Okay, so it says no life. I'm not sure what that is. Okay, so this is so when I had mentioned that one of the ways you can show you this. At face value, one of the easy way you can differentiate between a 15 inches and a 16 inches, because if you spot the both machines from afar, or if you're not fully familiar with the designs, you might not be able to tell because the inches between them are not so evident. So this is a 15 inches and this is a 16 inches. One of the ways you can easily spot that is you see the touch bar, the power button as well as the touch ID and the escape key are separated. On the 15 inches, the power button, there is no physical separation between the power button, even though it's the power button and the touch bar are not one, but there is no physical separation between the power button and the touch bar. And the escape key is also part of the touch bar. So the touch bar on these ones, they are not the touch bars are not they are not part of the touch bar itself. However, there is no physical separation compared to this one where you have a physical separation of the touch bar and the touch ID as well as the escape key. So this is a 16 inches and this is the form factor of a 15 inches. So that's one of the ways you can easily differentiate between 15 inches and the 16 inches. And then again, one of the easier way as well is the screens, to differentiate the screens if the screens are out. But 15 inches, it will have a lead sensor cable. Sorry, the 15 inches will have no lead sensor cable, while the 16 inches will have the lead sensor cable. Because I mean, the lead sensor cable was first introduced on the 16 inches A2141. So that's, say if you have both screens, one of the ways you can tell is one will have the lead sensor angle, the lead sensor cable, while the other one will have no lead sensor cable. And if the lead sensor cable happen to have been taken out, you will find the spot for the screw that goes onto the hinge to tell you like, yeah, this has a lead sensor cable. Okay, so that is that. Now back to why we are here. So the device says it's a no power. So among the batch that came to, we actually had quite a lot of 15 inches and the 16 inches. So you guys might be wondering, we just 15 inches in 1990s. Okay, so yeah, let us see what it is that we are dealing with. It says it's a no power, and we see one of the screw missing. Okay, let's take out the remaining. If this is the first time you're doing this, please be aware of the screw sizes. They are not of the same. The ones at the front will be of the same size. They are relatively shorter in size compared to the two at the back. My fingers are quite cut short, so I'm a bit, then I have to struggle now to get my back cover out. Okay. Mm. This is a familiar one in terms of the build up of dust on the side. So, okay, first thing we're going to do for A1990s, we are going to disconnect the power to the board. That's not peculiar to A1990. That is standard across all machines. When you're working on them, the first thing you want to do is you want to identify the source of power to the device. Obviously, you make sure your charger is not connected in the first place, and then identify the battery, where the battery connects to the board. You disconnect that, and then what we will then do is we will then check for a short on your PPBUS, especially on the A1990s. So we want to see if we have a short on our PPBUS. We are going to use continuity. This guy is quite loud, so we like to use it. So let's see, it's confirmed. Okay, that's our ground. So we want to have our black probe on ground. We can use one of the cowlings for our ground, and then we use our red probe. We want to see what we have on our PPBUS line. That we can confirm from any of these fuses here. What do we have? We do not have a short. Okay, that's fine. Okay, we don't have a short. So especially with the A1990s, when you have buildup of dust like this, you would expect that a C9081 has failed, and then you have a short on the PV But this one, we even though that's even though the board is quite dusty, which is expected of an A1990, but then we do not have a short on our PP bus, which is good. So the next thing we want to now understand, since we don't have a short on the PP bus, let us see, do we have a short on a 2.5 volt line? See, 2.5 volt line, that should be ground, and then the other side. Okay, so we have a short on the 2.5 volt line. Okay, and then the other side. Okay, so what am I doing? So I just checked for a short on a PPBUS rail, and we don't have a PPBUS rail, but we do have a short on we do have a short on the 2.5 volt line for the SSD. So let's see what that is. Okay, so what we've just checked, we checked to see if we have a short on PPBUS using the fuses here, F7000 and F7001, and we don't have any. And then the next thing we did was to check for a short on our 2.5 volt lines, which is still on the SSD region of the board. And we have a short on 2.5 volt line. And we are hoping that the short is not coming from any of the LANs, because if that is the case, client is going to lose their data. So let's quickly take the board out to find out what is it that is happening there. So we start by taking out our T5 screws. And on this board, even though C9081 doesn't seem to be an issue, we are going to take it off the board just as a preventive measure. Okay, T5 done. Let's now move on to T4 or T3. Myself, I'm using a T4. Sometimes your T3 bit might be a little bit of the size of the T4, and that will work for you. So okay, screws for T5 are done. Now we are going to take out the battery screw, as well as the two big screws which are holding our heatsink on the right and then on the left. And then be very aware that even though the screws look very familiar, the one on the right holds a screw on top of it, so it's going to have a hole on top, while the one on the left does not have a hole on the top. So for that, we're going to need a T8 or T7, whatever it is that works for you. Okay, and then the battery screw, that'll be the last one. And for these screws, you don't remove those. You only do so if you're going to remove the battery. Okay, now let's disconnect the cables. You can use a tool, but make sure you don't hand over complete control to your tool. Wherever you can use your fingers, it's best to do so. but places where you cannot, you can use a tool, but do not hand over complete control to your tool. Okay, so the fan duct it's stuck to the fan, so we removing that, making sure that whatever form of resistance you're getting on the board is taken care of before you take the board out. Okay, so the first thing we're going to do is to dust out. Let's dust the shell out. While you're doing this, be careful of the cables. You don't want to rip the cable out with whatever you're using, especially on the side of that's a Touch ID cable. So you don't want to break that. Because when that breaks, you can replace it, but then the Touch ID function is not going to work. It would mean that you can only use the other functions, which is to power the machine on and off, put the machine to sleep, lock the machine when it's booted, but you can no longer use the Touch ID. And that's because the Touch ID is paired directly to the board. Okay, so that's done. Now to the board. On the side here, we want to dust from the side, dust out the board from the side, and then we want to flip the board over to see. So the 2.5 volt, the short that we have in here, I'm pretty sure that it's going to be on the other side of the board here. So what I'm going to be looking at is I'm going to be looking at, I'm just hoping that it's not NAND related, and then I'm hoping it's one of these guys here. But I don't want NAND to fail, because when the NAND fails on this one, client's data is gone, and then the price or the repair fee, it's slightly higher than the standard no accessory replacement. Okay, so let's flip the board to the other side. Interesting. So we see that C9081 is actually not looking good, but we do not have a short on our PPBUS. I'm just going to confirm that again, because just confirm that again. We don't have a short on PPBUS, but we do have a short on the 2.5 volt line. And C9081 is not looking good, which is expected considering the amount of dust buildup that is there. So let's clean that. We are definitely going to remove C9081. Okay, so that guy, yeah, that's all we need to do. And now this is the guy that looks to be our problem. You see that guy there? That's a capacitor sitting on a 2.5 volt line, this one here. So I was hoping that my problem is one of these guys, and this is not looking good. So what we're going to do is we are going to take that off the board, and we're really going to hope that that is our problem, because I don't want to have an issue with the A1990. It's not a difficult repair, but it's just that the client is not going to get data back. So let's hope that our problem is only C9088. Actually, you see, actually, it's actually a good thing that this is coming in for repair, because if this has stayed longer, chances of the capacitor burning a hole on the board and damaging U9080 would have been it's quite high. So let's remove C9088 and hope that that's the problem that we have with the board, and that way client's data also get to be saved. Okay, that's out of the board. Let's check again. Left probe on ground again, and then right probe. Alhamdulillah, that's our problem. Alhamdulillah, that's very good. That's ground, and that's the 2.5 volt line. So, okay, yes, our problem was C9088. That's very good. C9088, and it's actually a good thing that the device is coming in now for repair. Otherwise, C9081 would have also failed. Let's grab another board for replacement. For the replacement, I'm using the exact board, but it doesn't have to be the exact board. You can grab that capacitor from any board. It doesn't have to be the exact board. Who is that? Anthony. Anthony, why are you walking like a big man? Anthony? Oh, okay. Okay, so that's all we need to do, and it's actually good that client's data on this it's going to be saved still. And I'm also going to mention sometimes you may have a situation where so sometimes you may also have a situation where after a repair around the region of the SSD is done, you may have the device not starting immediately, and that could mean that the device is stuck on recovery. You want to hook the device up onto your DFU, your Apple Configurator 2, launch, put the device in DFU mode, and then you want to revive the device and not restore because restore will erase your files. Okay, so let's dust the board folder, and hopefully this should be a completed repair. Ideally, I wouldn't have all of the cables connected. I would connect only the cables that we need for testing. But I'm kind of a bit confident that we might not have a secondary issue. I don't need the battery cable, the battery screw to start the device, but I'm just adding that. Okay. Now we can connect power to the board. And also, you see why again I keep mentioning, if you do not know the state of the machine, do not plug power to it. Imagine if you have plugged power to it and see C9081 died in the process, and then you have like a multi-layer issue other than the issue that you're having. So let's connect power now and see what we have. Have trackpad feedback yet? No, no trackpad feedback. Now we have trackpad feedback. We're hoping that the fans are starting, and we're hoping that we're gonna get Apple logo soon. It's the device. That's it. That's a beautiful Apple logo. It crashes. That is standard because of the section of the board that was affected. We're just gonna do a PRAM. Can shut it down for the client and do a PRAM for the client. Uh, let's do a PRAM for the client. Okay, so that's it. We are not going to expect to see the crash error anymore. That crash error would have been saved from when the device died. Okay, so the fact that it's booting means the client's data is still intact. Okay, we're not really going to wait for it to boot to desktop. As you guys can see, the device is completed, and the issue we had was on the 2.50 line, and that was because of C9081 that has been replaced, and we have a working device. So we are quickly going to put the device together. It's already been cleaned, so let's quickly put the device together. Anthony, I'll boot in a few minutes. Just a few minutes. Let's quickly put the device together. Let's start with the T5 screws. T5 and the A1990, this is the one screw of the T5 that's going to be longer than the rest, and that was going to, I'm talking about the ones on the board, the T5s on, and that's going to be the one here. Now with the A2141s, you should have two of those, one on the right and then one on the left. Okay, T5, and now let's use our T8 for the heatsink. This is going to be the side, the one that has no hole on top of it, and the one that has a hole will be on the right. Okay, now let's put back the cowlings. And it's very easy to misplace or to place the screws wrongly on the cowlings, which is why it's important to, especially if it's the first time you're doing this, to identify the small size screws, the T4, T3 screws, so that you place them where they're supposed to be. So one of the ways your fellow techies will judge you as to how good you are, it's your placement of screws. So once they see that screws are not properly placed, they just assume that whoever did the job is still coming up. We all are coming up, and so the beauty of the job is every person it's actually uh, in some level. So, but there are universally accepted levels. The very least of it is, if you cannot make it, don't break it. I mean, that's universally accepted. That has nothing to do with level to say. I mean, so that's just like the basic. So you not being able to place your screw, chances of that is you can easily long screw damage a machine, and then you just make things difficult for the owner, and then the sad reality is the owner wouldn't know. To them, it's the same thing. It's a no power, no power. But you just damage the client's machine, and yeah. So best thing, take time to understand your screws, know which is which, and yeah. The argument of Apple not really wanting people to fix their devices, you see, most of the time it's very legitimate, especially when you see sometimes how we techies handle the devices. So, but if you do it the right way, then yeah, then that's the best thing you could do if you choose to do it as a job. So if you're not familiar with the sizes, you can take one of the lines. For example, take an A1990 machine and then look at all of the screw sizes, especially the ones that will seem confusing to you. And then you use that to model for all of it in terms of all of the A1990s. And then each time you have an A1990 to repair, you know exactly what goes where. Same thing with the A2141, same with A1706, A1708. I mean, the same approach goes for all. Once you understand one, you will understand all in terms of disassembly and assembly. Okay, that's it's the last screw. We're now going to connect the battery cable as the BMU cable and the BMU cover, and put the back screws back, and that's it. So we're going to dust the back cover as well. Okay. When you close the back cover, remember to snap the sides in place. That and that. This was the one that that one screw was missing here. So we can just get another screw for the client. I want to get the exact screw. You should have more than one of those. Mm, okay, there we go. Okay, that's it. So see the device starts. I'm going to hold down the Alt key because I don't want the device to boot. So yeah, a bit of a recap. This was a no power repair. We found that there was no short on the PPBUS, which was expected, but there was a short on the 2.5 volt line for the SSD, and then I was hoping that it's not NAND related in terms of one of the NAND chip failing, and alhamdulillah, it wasn't a NAND chip, it was a cap. So we played the C9088 and the short was out, and then that was the fix for this one. So I don't want to put the device on desktop because I mean, there's no need to go to the client's or personal login screen. So, but as you guys can see, we now have a working device, and thank you guys. I will see you guys in the next one.